Hello, geometry scholars. This is Mr. Benzel here, and today we're going to be talking about algebraic proofs. And proofs, do kind of have a reputation on the street as being difficult, and I am aware of that. I will tell you, though, that proofs are difficult for people, not because proofs themselves are difficult, but because we just haven't been used to, geometric concepts and geometric notations. And for that reason, we're going to kind of develop proofs today with the algebraic proofs. And I think it's important that we do that because we've been kind of communicating with numbers and algebra for, 10 years or so. So a proof simply is a logical step-by-step argument with statements backed by reasons. And you can kind of think of proofs as sort of the exercise of almost like writing an English paper in math class. All right, I'm going to be honest with you about a few things and how to approach a proof. So the only way to learn proofs is one, knowing your vocabulary. If you know your vocabulary, not only you're going to get good at writing proofs, but it's actually going to help the earlier geometry problems feel a lot easier. It's also important that you're studying proofs that have already been done. So my hope today is to give you a few proofs in this video that are already done that you can study from and kind of look for some patterns as well. Another thing that people find it helpful to do is think about, how do I get from one step to next step? And another thing that I think is important, and this is going to maybe not make you feel good initially, but in the long run, it's going to be really good for you. You may not get proofs 100% immediately, and that's okay. People who are able to come to terms with that and really take the effort to do kind of these three things above actually find themselves becoming a lot better as a scholar and are able to kind of handle challenges better as well. So let's get started. All right. So in the beginning, there were the properties. So I'm going to just kind of develop some of these basic properties here. The first property is called the reflexive property. And it's also called the identity property, or my nickname for it is the duh property. So this says that A is equal to A. And I could have a reflexive property of line segments as well. So I could say that AB is congruent to angle or segment AB. And I could also say that for angles, let's say I have an angle called angle A. I could say that angle A is congruent to angle A. Then we have a symmetric property. So this says if A equals B, then B equals A. So where this comes from is, let's say that John says X equals 5 when solving an algebra problem, and Danny says 5 equals X. They are the same thing. They mean the same thing. The order of the equal sign does not matter. So for line segments, we could say if AB is congruent to CD, then CD is congruent to AB. And then for angles, if angle A is congruent to angle B, then angle B is congruent to angle A. So where I'd like people to kind of get to, by the end of the term is having at least really good property recognition and being able to kind of recognize these properties. You don't have to memorize them word for word, but if you're kind of seeing, situations like this, you could say, oh yeah, this is the symmetric property, or, something congruent to itself or equal to itself is the reflexive property. All right, the last one is called transitive property here. So this says if A equals B and B equals C, then since A is equal to B and B is equal to C, A has to equal to C. So for line segments, then we can kind of extend this with the congruent symbol. So if AB is congruent to CD and CD is congruent to EF, then AB has to be congruent to EF. And you can always recognize the transitive because it's kind of the longest one. It's kind of operating like therefore. So if A equals B and B equals C, therefore A equals C. And then for angles, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. So I suggest that you kind of take a pause here and write the properties down, or if you're doing a screenshotted version of your notes, you can take a picture of this table and use these properties as you kind of embark on proof writing and answering, the property recognition questions on Delta Math. All right, a few properties that are kind of specific to algebra proofs. Addition property, this is just anytime that you add on both sides. That is the addition property. Subtraction, this is subtracting on both sides. Multiplication, take a wild guess. This is multiplying by the same number on both sides. And I must say that for addition and subtraction, you are, adding and subtracting by the same number on both sides. Division, dividing by the same number on both sides. Distributive, example would be, A times B plus C. You just distribute AB plus AC. And then substitution, if A equals B, you can substitute B in for A in an equation. So this is kind of like, plug it in. So if you hear your algebra teacher say, plug this in, you are actually technically speaking performing the substitution property. All right, so we're actually going to a pretty basic algebra 1 example of a multi-step equation, and I'm actually going to turn it into a proof. And it actually is not too hard to do that. If you are helping your 8th grade friend, do a multi-step equation or something like that, you actually are kind of almost treating it like a proof. All right, so if you're kind of helping your friend do this problem, the first thing that you're going to tell them to do is to distribute. So I'm going to write this as 8x minus 12 equals to 28. And what I did is I used the distributive property. And I will tell you that a lot of properties in algebraic proofs, do make sense because, it's pretty much what you are doing to get from one step to the next step. All right. Then I'm thinking about what do I do next? I would tell my friend, I want to try to get that x by itself. So I'm going to add 12 to both sides. So I'm going to get 8x equals to 40. And when I am adding to both sides, that is the addition property of equality. And it's of equality because we have an equal sign. And then I'm going to divide by 8 on both sides. So I am left with x equals to 5. So that is the division property. And one of the nuances of proofs is that the first statement is always given. So we are given a problem. And guess what? We have actually created a proof, believe it or not. So what we're going to do now is just turn it into a table. So I'm just going to get a little different color here. Maybe I'll do dark green. So we have, for the steps, we call those the statements. And then obviously when we're going from one step to the next, we call that reasons. So this is how do you get from one step to the next. All right, let's actually see a full-blown algebra proof now. This is example 2. Actually, it really is not too much more than what we just did, except they do give you kind of that statement and reason table. So let's actually go and do this. All right. So you're always going to kind of start out with the given. And the first thing that we can kind of see here is that we have parentheses. So when we're kind of like applying those parentheses, that's going to be the distributive property. So I'm going to write 55z minus 27z minus 36 equals to negative 64. When you see the terminology simplify, this is also kind of like combine like terms. And if you want a refresher course for combining like terms, some people kind of find it helpful to, circle. It's like you could circle the 55z and the minus 27z. So 55 minus 27 is 28z minus 36 equals to negative 64. All right. So then what I'm thinking about next is what do I do to get from one side to the next side? So I want to actually get this 28z by itself. So I'm going to add 36 to both sides. So that is the addition property. And if you want to, you can actually kind of between the lines or maybe on a piece of paper, kind of show this is not required, but it's kind of nice to have. You can kind of see how that addition property is playing out. So I'm going to do minus 64 plus 36. And I'm going to get minus 28. So I have 28z equals to minus 28. And let me just clean that up a little bit and make it nice and neat. And then I'm just going to divide both sides by 28. This is the division property. And these are all properties of equality here. And I'm just going to divide by 28. And I'm going to get that z equals to -1. So that would be your last statement. And this is an algebraic proof. So an algebraic proof really is just like solving multi-step equations in Algebra 1 class, but then just justifying how you got from one statement to the next, just telling us what you did. So if you're kind of coaching your 8th grade friend on like how to do this problem, and you're saying things like, oh, you just add on both sides. Oh, you just subtract on both sides. If you add the word property to it, that's really what you're doing, and you're actually kind of creating a proof style argument when you're doing that. So the Delta math is kind of like teacher created problems, but it's meant to kind of give you some good practice with algebraic proofs. So I'd like you to try your best on it, and it will also be good. It will give you some feedback. So I am looking forward to seeing what you know.